10 years ago, I could not have imagined standing here in Sweden talking to you about acoustics, especially acoustics in a neonatal intensive care unit. Neonatal intensive care unit, it's an intensive care unit where they take care of small children, children that were born early, too early. Yeah. 10 years ago, I became a father of my first son. My first son was born at 26 weeks. Normally you should take it up to 40 weeks. It was 725 grams, so it was a little bit of a surprise to me and my wife that we became a parent that early. And we had to witness at first hand, during the first month of his life, the environment of an intensive care unit, yeah, which is a quite shocking environment, especially acoustically. Since I'm an acoustician, those environments are not acoustically friendly. So today I would like to show you some of my, or let's say share of my experience of designing a new intensive care unit. This is the intensive care unit of the Leuven hospital, the University Leuven hospital. So just to show you, yeah, I'm going to tell you the story about how we did it, and I hope you can learn from it. So let's have a look. Does it work? Yeah, okay. So the outline of my talk is going to be first look, how is the situation in the old neonatal intensive care unit? So where do we come from? Secondly, I would like to focus on the acoustic design of the new unit. And to me, a good acoustic design is based on 3 basic pillars, and I'm going to come to that. Yeah. And finally, I would like to conclude, like, does it all work? Do we have the results we wanted to have? Okay. So, this is a typical picture of a neonatal intensive care unit, so of the old unit. And I guess most of the neonatal intensive care units in the world look like this. So how do they look like? It's like a room like we are here. And they stuff it with a lot of medical equipment, incubators, children of course, a lot of medical staff, feeding pumps and so on. And the main problem there is that people and the machinery are constantly contaminating each other with their noise. Yeah? So it's never quiet. So if you start measuring the noise levels in such a room, you end up with a graph like this. So on the graph you see we've been measuring for a few days, night and day, and what you can see is that the background noise, that's the blue curve, or let's say the purple curve here, never is below 50 dB. The LEQ levels, yeah, are always like 60 dB. And the maximum levels, so the peak levels, are between 70 and 75 dB. It's 24/7. There's no difference between day and night. So do I need to ask you if a quality sleep in such an environment is possible? And as we all know, it's very important for little babies that they can sleep, because that's what they do. They eat and they sleep. Yeah. And especially preterm babies, they have their brain is still in a lot of more development, so it's very important that they can have a quiet environment. As you know that your sleeping room in this hotel should be, let's say, less than 30 dB in the background noise, and we're coming from more than 50, yeah. And the peak level should be less than 40 or 45, otherwise you will get awake. And we're speaking about 70, 75. It's a huge difference. Yeah. Also, another question you can ask, if it's a quality work in such an environment, is that possible? And as we know from the conference also here, the answer is of course no. A lot of research shows that it is quite impossible to work, to concentrate your mind in such a noisy environment. And the stress levels in the people who are working there are increased even more just because of the noise. So when 10 years ago, when I was there as a father, I heard the people of the team were considering of building a new unit. I was very interested, especially because they had really innovating ideas. They wanted to make a kind of whole new concept that was never done before worldwide. Yeah. And I volunteered to help them with my acoustic knowledge. Yeah. Because if you write a new chapter, of course, new possibilities and responsibilities appear. So what was the main focus for them? The main focus was to have a single room for every baby. So this is how it looks like. Yeah? So you see all the single rooms, and they are, let's say, positioned around 3 bays, 3 circles. So one circle, second, and a third one. And they are connected with a small corridor. The yellow areas are the rooms. Every baby has got its own single room. And on the outsides of the base, there are some little more bigger rooms for the twins, because sometimes they have twins, brothers and sisters, who get born on the same day. Yeah? Okay. The outside of that system is like our corridors, but they call it the outer base, and that's, let's say, where all the circulation happens with the parents. The parents get a hotel badge, so they enter, they wash their hands, they get a hotel badge, and they can enter their own room. And the inner bay is meant for the medical staff, so doctors and nurses work in, let's say, a kind of an open space, open plan office. Yeah. And they enter the rooms from the inside. Between those bays, you have some common rooms with utilities, where they can find all the stuff they need to take care of the babies. So that's the main concept. Now, when you look to the acoustic design of that system, to me, I think you can only be satisfied with a good acoustic comfort if you have three basic pillars. And those three basic pillars need to be in balance, because if one of them is not strong enough or out of balance, then you will have acoustic complaints. So the first one was limiting the background noise. The goals we used for the single room units, well, we just used, let's say, the Belgian building standards, because for us it was the easiest way to convince other people in the design project to apply to just the standards. Yeah? And the standards say, look, you should have a background noise in your sleeping room of around 30 dB. Another important part was like that the influence of the noise made in the adjacent rooms, and it could be more than 75 dBs, should be limited to, let's say, 3 dBs in the room you want to, where the baby is. And for the inner bay, well, it's like an open bay office, so we wanted to have a background noise between 35 or 45 dB. Yeah. What are the most important sound sources in this concept? Well, first of all, you got a ventilation system, which is quite obvious, but it's a special ventilation system due to high hygiene demands, so there was a fine dust filtering. Secondly, also in Belgium, just like in Sweden, we are familiar with the phenomenon of rainfall. Yeah. So, and they were lucky to have their unit installed on the top floor of the building. So, but then you have daylight canopies, and daylight canopies can be very noisy when rain is falling. Another source were the water faucets. Inside every room there's a water faucet, because you need to wash your hands very often, also inside the inner bays. And every time you use that water faucet, you create a lot of noise, yeah? At least in the old rooms. So how did we do it? Well, for the ventilation system, the most important parameter we use is just reduction of the airspeed. So that's quite obvious. Yeah? And rainfall, well, we used laminated glass instead of the more traditional plastic domes they use for daylight canopies. So we don't have any noises from the glass. And for the water faucets, all the metal sinks were removed. We use stone metal sinks, and we have been looking for silent faucets, water faucets, and really they do exist. If you start looking for them, you find them. Yeah. Okay, second pillar is soundproofing of the rooms. We wanted to have a good speech privacy between the rooms, because you don't want to understand, let's say, the talks of the people next to you in your room. Also, it was important that the noise or the talking in the bays, the inner and the outer bays, would stay in the inner and the outer bays and would not able to penetrate into the rooms of the small babies. And I'm not showing you here in this project, but there are also other rooms like offices, even a morning room, and small children die. It's very important such environments or such rooms also have a good soundproofing. Yeah. And keeping in mind that in one room there could be like 75 dB maximum sound level, because there's a crisis going on, a lot of people going there doing surgery and so on. And next to that there's a baby sleeping. You could compare it like somebody's vacuum cleaning next to your sleeping room, to your bedroom. Yeah? So you need a high insulation level between those rooms. So we came up with, let's say, a demand of like 50 dB between the rooms and 35 dB between the room and the bay. Okay. So how did we do it? Well, between the rooms we used traditional hollow gypsum board walls because they are light, they're thin. You're on the top floor, so weight that really doesn't matter. Yeah, it doesn't matter. So they're light, they're thin, dry, and fast to build, and also they're hollow, so you can put in lining, ducts, electricity, gas, and so on. And they are so relatively cheap, which is important. Yeah. But if you use such a system, the devil is always in the details, like a lot of things in life. Yeah. And acoustically, you need to be very aware about air tightness and leaks. Leaks, also flanking noises are very important. And especially in our case, the ceiling was a very delicate construction. So we really wanted to avoid perforations of the separating wall. And we wanted to have a robust solution, because in those projects, the contractor who is executing the work most of the time is the cheapest one. Yeah. So they don't have the time or the effort to really pay attention to delicate acoustic details. So what did we do? Well, especially about the technology, and there's a lot of technology in such a high-tech environment. I mean, you've got oxygen, you've got internet connections, you've got electricity, all kind of wires. It's really a big bunch of technology systems that needs to be integrated in a room. So we designed, let's say, a technical shaft at the backside of every room, where you could lead into the lining into the hollow walls. Yeah? By doing so, you only have to make perforations in one side of the wall. You don't touch the other side of the wall, which is important. Yeah? And the supply of those technical shafts is done by the outer corridor, the ceilings in the outer corridor. So the perforations are only made in this wall and not in the really separating wall between the rooms. So that's really, we didn't touch it. And finally, the third pillar is limiting reverberation time. So the room acoustics. The reason why, we all know it. Yeah. If you don't look into the reverberation time, you end up in a situation like this. And this is especially the case, let's say, for the inner bay. The inner bays, because over there it's like an open plan offices. People, doctors, nurses are just talking. And we had a big issue there, because how did we do it? Well, first of all, as acousticians, we did our job, so we did some acoustic modeling. We tried to, let's say, predict and calculate reverberation times. We wanted to know the Lombard effect, when does it kick in, and so on. Yeah, and we wanted to find some solutions for the choice of materials. But we had a problem because of hygiene demands. The engineers of ventilation and cooling, they really demanded a closed metal ceiling. So it's a metal ceiling, and on top of that metal ceiling, cold water is running. Yeah, so for cooling ceiling during summertime. But they really demanded a closed metal ceiling. So as a consequence, our reverberation time that we predicted was more than 1.5 seconds, which is a lot for such a pretty small room. Yeah. So how did we solve it? We solved it by attaching the Ecophon Master solar islands on the metal ceiling by using magnets. Because it's a metal ceiling, you cannot drill them. You click them on the metal ceiling, and the results are really good for that. Yeah. So does it work? Well, this is a histogram of the old unit. So what you can see is that during 16 hours a day, you have at least a noise level of 45 dB. So it's measured outside the incubator of a baby. And only during 8 hours a day, so during even 8 hours a day, it's more than 60 dB you have. So that's the situation like in most intensive care units, neonatal intensive care units in the world today. And now, if we do the same kind of measurement, that we see during more than 16 hours a day, you can enjoy, let's say, a background noise of 41 dB. Yeah. While 8 hours, you don't even reach the 50 dB. Well, the background noise used to be more than 50 dB, 24 hours a day. So really, it does work. So it's not surprising that the parents and the medical staff, but especially the parents, really appreciate the big advances in acoustics made in that environment. As a kind of a take-home message, this is for me again a typical example, like we encounter a lot, is to really find a balance when you're designing buildings, and especially unique settings and technologically advanced buildings like an intensive care unit. that you need to find a good compromise and a balance between all those demands, the demands between thermal comfort, visual comforts, like we mentioned in the previous presentations, air quality, hygiene, and of course it has to look right also. Yeah? Well, you have to be able to blend in the acoustic comfort also. Yeah? And to conclude, we found now we have a silent, let's say a silent room for the babies. We find new problems appear. And one of the first one now is that we really need solutions for reducing the noise of the incubator, because if you start measuring inside the incubator, you find noise levels more than 50 dB. Often them they are tonal noises, so not natural noises, yeah? And they must be stressful for the babies too. In the old unit, that was not relevant because we made more noise outside than the incubator is making or was making. So, but now the incubator is the most important noise. And also, like, there's a final point is, like a lot of things in life, if you have benefits, you also have drawbacks. And now we can see that sometimes the rooms are too silent, especially when the parents of the baby cannot be there. And they are left there for hours alone in a very quiet environment. And it's been shown that it can have a negative effect on the development of speech. So now we're doing research in the university also on providing prenatal noises, so like recording the voice of a mother. And they're measuring stress levels and so inside the baby. And I'm also very interested in soundscaping for using in that environment. So that's the end of my talk. I was happy to be able to talk to you about it. If you have any questions, shoot them, please.